All right, guys, today we're going to learn area of a sector and arc length. So these have to do with area and circumference of a circle. So if you notice here, we're going to start with area of a sector. We don't want the area of the whole circle, we just want the area of the shaded piece. But it does have to deal with area of a circle. So if you remember back to Tuesday, I believe, area of a circle is pi r squared. So notice that is part of your formula, pi r squared. So you want to take the total area, the area of the entire circle, and right here you only want a piece of it, right? You want a piece out of the total 360. And that's where this formula comes from. So you want to take your entire area, pi r squared, and then again you only want a piece of it. You want a piece out of the total 360. So this is the formula you're going to be using for area of a sector. So notice here my central angle is 70, my arc is the same. So we say, hey, area of a circle is pi r squared. Right? We want area of a circle. And then again, you only want a piece out of the total 360. So that's where our formula is coming from. So we want a piece of the area. So let's plug in pi. Radius is 6 squared. We want to deal with 70 degrees out of the total 360. And that will actually get you a percentage of the area. Now, it does ask for two answers in terms of pi and rounded to the nearest hundredth. So let's start with in terms of pi. I did attach a calculator. So we're going to travel over to that calculator. When they say in terms of pi, that means you want to do everything except for pi. So don't type in pi. So what do we have? 70 divided by 360. And this is your EOC calculator, so I would get used to using it. 6 squared is 36, so times 36. And again, notice I left pi off, so I have 7. We're going to come back here. We have 7 pi. Since we're talking in terms of area, we have centimeters squared. So this is in terms of pi. In terms of pi means leave pi alone. That's also exact. Then you're going to come back to your calculator. We need to do 7 times pi, so 7 times 3.14. So 7 times 3.14, 21.98. So about 21.98, which happens to be the nearest hundredth, centimeters squared. So again, they're asking for two different answers, exact in terms of pi and rounded to the nearest hundredth. All right, let's try another one. So here we've got pi r squared, so pi times the radius, which is 9 squared. And again, we don't want the entire area, we want a piece. We want 120 out of the total 360. So we're going to come back to our calculator. We're going to go ahead and do exact first, leave in terms of pi. So we're going to do 120 divided by 360 times 9 squared, which is 81. So I got 27 this time. So we're going to do 27 pi, because we haven't touched pi yet, inches squared, because we're talking in terms of area. And then you go to your calculator and do 27 times 3.14. And you should get 84.78 inches squared. Now the next one, notice I don't want all of this sector. So I just want this little slip right here. So let's start with area of a sector. Let's find area of a sector first. So we're going to write sector. It's still pi r squared, so r is 2 squared. And then again, you don't want the entire area, you want a piece. Looks like 90 degrees here. 90 degrees out of the total 360. We're going to type that in our calculator. So what did we have? 2 squared, which is 4 times 90 over 360. And I get 1 pi, which is 1 pi is 3.14. We're just going to write this as 3.14 inches squared. All right, so that's the sector. That's the sector. That means that's all of this. That's everything. Well, we don't want everything. We don't need this triangle here, so we're going to subtract it out. So let's find area of that triangle. Remember, area of a triangle is 1/2 base times height. So we have 1/2. My base and my height are both radius. The radius of the circle. So this is 2, this is 2. So times 2 times 2. So 2 times 2 is 4. Half of that is 2 inches squared. So that's the area of this triangle. So we have our total area is 3.14. And we don't want the triangle, so we're going to go ahead and subtract out that triangle. And you're left with 1.14 inches squared. And that would be just that little shaded slip. All right, we're going to skip number 4. We're going to move on. Flipping over to the other side. Arc length. So area of a sector dealt with area of a circle. Arc length is basically the distance around from A to C in this case. This is a piece of your circumference. So arc length is a piece of circumference. So if you notice in the formula, 2 pi r, that is circumference of a circle. But again, we don't want the entire circumference. We just want a piece out of the total 360. So that x out of 360 is still staying. So again, area of a sector deals with area of a circle, and arc length deals with circumference, right? 2 pi r, the distance around is 2 pi r. Arc length is the distance around, is circumference. So let's try a few. So we're here. They want to know from A to B, what's the length of this arc? They want to know what the length of the arc is. We're going to use our formula. Again, when we think of length of arc, we think of circumference. So circumference is 2 pi r. And again, we don't want the entire circumference. We want a piece out of the total 360. All right, so we have 2 times pi times my radius, which is 18, and then 1/10 out of 360 is the piece that I'm looking at. And we're going to type everything in except for pi, because again, they want it in terms of pi and rounded to the nearest hundredth. Okay, so we're going to come back to our calculator. And we had 110 divided by 360. And then we wanted to multiply that by 2 and 18. And I got 11. So we come back here. We have 11 pi inches. Again, this would be in terms of pi or exact. This is exact. Go back to your calculator, 11 times 3.14, and you should get 34.54 inches. This is rounded to the nearest hundredth, tenths, hundredths. All right, let's try another one. Here they want WX, arc WX, they want the length. So again, when we think of length, we think of 2 pi r, we think of a piece of the circumference, right? A piece out of the total 360. So we got 2 pi, radius is 14, x out of 360, we want 90 out of 360. This will probably be the last one that I use the calculator on, and then, you know, you guys can use the calculator on the rest of them. So where are we at? 90 divided by 360 times 2 times 14. And I got 7 pi. So we have 7 pi centimeters. Again, that's exact. That's leave in terms of pi. Then they wanted rounded to the nearest hundredth, so you're going to type in your calculator 7 times 3.14, and you're going to get 21.98 centimeters. There's exact, or sorry, there's rounded to the nearest hundredth. Exact, leave in terms of pi, and rounded to the nearest hundredth. We'll do one more and then I feel like we'll be good. All right, so here we're dealing with 2 times pi times r, and we want 36 out of 360. 2 times 20 is 40, times 36 over 360. If you type that in, you get 4 pi inches. There's leave in terms of pi. Again, don't touch pi. And then 4 times 3.14 will get me rounded to the nearest hundredth, 12.56 inches. All right, so that's what you're doing on these. Now the worksheet you have, so make sure you do the worksheet first. One side is area of a sector, and the other one is arc length. I swear these were shaded. These were shaded when I had them, but I guess the shading went away when I copied it. So here, this all should be shaded, shaded. They talk about area. It's wherever the loop is. So here, this is shaded. Here, all of this is shaded. So those loops are where you're finding. But same concept. Use your formula for area of a sector. Area, pi r squared, x out of 360. Arc length. Arc length, same concept. We want the length from P to Q. Oh, sorry, from P to Q. And they give you that 210. Use it, 210 out of 360, and then use your circumference, 2 pi r. So go wherever here use the 125 for RS. But go wherever the loops are. Here use the 240. All right. So that, make sure you show all of your work. This one does say round to 2 decimal places. Okay, and use 3.14 for pi. This one does say round to 2 decimal places as well. Okay, and they give you an example up at the top if you need another example. The last one, this is everything combined. If you want a little extra credit, show me that you really, really know this stuff. Do this and I'll give you some extra credit. Okay, this is due with the homework as well. There'll be a separate column. Make sure you upload it in the extra credit column. And this one's asking for both. So it gives you a picture and it wants you to find the arc length and the area of the sector. Make sure you show all work on everything. I expect all work, everything that we did on here. Okay, show me what you plugged in. I expect to see on your paper. And that includes this and the extra credit. Okay, so you're going to have to show work on your extra credit. All right, bye guys.